Repeat the process.
Part 2. Wait, how do you say part 2 in sign language?
So now I have 0.5
Where's she at? Dictionary.
plus 4
Where's she at?
divided by 4. Oh, 1 again. Woo. So multiply by 8 is going to be 0.25 again. And I'm going to get what now? 4.75. Repeat the process. 4.75 goes here. Plug it in here, you're going to get a 1 again. Which means it'll be 0.25 again. But now you're adding 0.05. So I'm concerned that's 4 iterations, you're good to go. So when x is equal to 1, your value function is assumed to be 5. Watch this, please.
What is the third dy over dx say? Because it looks like it's 1, but it looks like it says 43. I'm telling you.
Next one, guys, ready?
No. Just 1 second. Okay.
What's next?
Oh, I thought you was singing. I know, right?
Oh,
When did it end?
this was me. Check it out.
Enjoyment.
Check it out. dy over dx is the slope, right? So you can combine what you learned in the last section with this new section and go to town. Your dy over dx is the slope shown on the slope field. This was a neat problem, but I don't think I want to go into it. Let's skip over it. I don't think we'll have time for it. It's not worth it. Okay. Next one. What's the next one? Oh boy. Exponential growth and decline. Exponential growth and decay. Let's do that one
It's
quick.
like highlighter videos on TikTok. It's
Let's do a
like,
couple problems in that one.
this is blue,
Okay.
and this is pink, and they're dating.
Oh, we're out
This
of
is
time.
purple and green, and they're dating. And they end up all cheating on each other.
Last section, exponential growth and decay. Remember, it comes from the differential equation dq's, dfq's, or dfq's. Dp or dt equals to a constant value times y. The change in y is proportional to y itself.
Wait, okay.
The result
get
of
here?
that is a solution C
Is this our homework? No, our homework is
times
like
e to
6.1 and
the
6.2.
kt
So
would
this is
equal
just
to d.
review. I mean, I wouldn't be surprised if it's. Yeah, he
These
said
problems are
it's a review.
usually in
I
regard
remember
to
that.
time, so your x value is actually t. Times of it. Okay?
Oh, I got new nails. Yay, they're so pretty.
So let's work
I know
out
they
some
were so
problem here.
long before.
The tire pressure is 45 psi, decreasing by
I need to
0.36
figure out
psi
my
per
nail
minute.
style. But to
At
figure out my nail
time,
style, I need to
the
find my
nail
baby
is
walk
struck.
dress.
Write the and
That's
solve
coming
the
up.
DQ.
Yeah. I have a couple contenders that I literally
Got
don't know
it.
what I'm wearing.
So this is your DEQ, right? Change in pressure per unit time. That number is given to us as what? That change in pressure is 0.36, right? And what's the pressure at time of puncture? 45. So K is equal to 0.36 divided by 45, which I get is negative. I'm sorry, this is negative. Why is this negative? It's decreasing, thank you. That will be negative 0.008. Using your calculator. So your equation is going to be right here, right? That's going to be P is equal to C e to the negative 0.008 T That's gonna be your formula. The solution to the differential equation.
That's my
You
daughter.
can't solve for C because you don't have another initial condition. Oh, yes, you do. What is it?
She's adopted an
You do. What is it? Duh. What's C, guys? Yeah, when T is equal to 0, the pressure is what? 45. So P is equal to 45 e to the negative 0.008 T. That's your formula. That's the specific solution to this general condition.
Dude,
Questions?
what does that say? I'll write it for you. Okay, because I can't read that. I'm really bad.
Cool.
Eyesight.
Yeah,
Yeah, maybe it's because you're not wearing your contacts. Yeah, I probably should.
Don't you want to on the float? I gave you a chance to work on your own. Way too long.
Okay.
Yeah. We good? So jump to the last page there. Yeah, very last page. No? Yeah, last page. Growth decay model, just second to last page right here. It puts it all together. It puts it all together. This is your differential equation. As a direct equation, this is your solution. Your solution to the specific one, right? So the question is, write the differential equation, this right here, and find the general solution right here. The rate of change for a P is proportional to P minus N. So this is basically saying that the rate of change, P over pt, is equal to, proportional to K times not P, but P minus N. Or N is some number.
Imagine they're just watching us. Watch us.
You good? How do I solve for the differential equation? Like terms. The P minus N goes over here, the T goes over here. So you can just switch the extremes here. And we dP over P minus N equal to K times dt. You good? It's separable, so you can separate the two. To solve, we integrate both sides with respect to differentials. This becomes P minus N in the denominator, so it's going to be the ln of the absolute value, P minus N. Right? Equal to what?
It's giving dude perfect.
KT plus C. Very good. If I wanted to solve for P, how would I do it? Yeah, right, e to the side, right? That would be e to the ln P, it's going to be P minus N, equal to e to all the stuff, KT plus C, right? Right. And that plus C is the constant, right? So that's the same thing as some constant e to the KT, when we talked about that yesterday. So P becomes e to the, excuse me, let's see over there. Like we did yesterday. That would be C e to the KT plus N. Questions? What time is the word problem? We'll try. Questions? You good?
So hungry.
Now, yes, use this theory to then proceed to the word problem at the bottom of that page. We have a cylindrical
You should
tank.
meet me in Ambassador Room today.
You want to fill it
We miss you.
with water and punch out a hole near the bottom. The water leaks out quickly at first, then
We're
slowly,
like the best.
as the depth of the water decreases, the rate at which the water height changes will change directly proportional with the square root of its height. Why is that? Because the cylinder's volume is pi r squared.
I really want to get my banana. I should have had it in first period.
So they tell you the differential equation, see it? The rate at which, or the height of the water in the can changes is directly proportional to the square root of it.
Why does it say it white?
So I'd write dH
That which? That's embarrassing.
over dt is equal to k times the square root of h. We good? What's k going to be? At t equal to 0, the height is 20. False, right? That's not really what I'm looking for. Is it? Yes, it is. The height is 20, the change is 5. So if the change is 5, and the height is 20, we get k is equal to, oh wait, is that decrease or increase? That's decrease. Why decrease? The negative 5 is decreasing. Yes, it's falling at a rate of 60%. So this is going to be negative 5 over the square root of 20, which simplifies to negative the square root of 5 over 2. We good? Cool. So my differential equation of dH over dt is equal to negative root 5 over 2 times the square root of h. What's the solution of that sucker going to be? I'm going to flip these up, right? I'm going to say dH over the square root of h is equal to negative root 5 over 2 dt. Got it? Got it? So when I integrate both sides, what do I get? I get 2 times the square root of h. That's the integral of that. Equal to, that's just a constant, negative root 5 over 2t plus c. We good? What's c going to be? Let's use that initial condition with now t equal to 0. At h20, t0 plus c. C will be equal to, that's going to be what, 4 root 5, right? 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 So this equation is going to be 2 root h equal to negative 5 over 2 t plus 4 root 5. Okay? Questions? Did you solve for h in that term? Guys, well done.